Alright guys, welcome to Kramer's rule. I know you guys are very excited about these videos going green, so now we're using a dry erase board. I know it's very exciting, so just try and stay focused. Now, what we're going to use this for is what we've learned so far is how to find determinants of matrices. Well, now we're actually going to use those determinants and solve systems of equations. So, system of equations, as you remember, are two equations and two unknowns. So we'll have like an ax plus by equals m, and then we'll have an fx plus gy equals n. Okay? Two equations with two unknowns. Here our unknowns are x and y. A, b, f, and g are coefficients of x and y, and m are our answers. Okay, so all a, b, m, f, g, n are all just numbers. X and y are variables. So it's first a good thing to establish what a coefficient matrix is. And I will denote that from now on as a matrix with a capital C. Okay, what this is a matrix strictly made up of the coefficients of x and y. So this is just a matrix with a, b, f, and g. Okay, that's all it is. It's just a coefficient matrix. It's in the name. Okay, so how we're going to solve for x and y is like this. X is going to equal the determinant of the matrix. Now, it's important to know what goes in this matrix. How this works, when we're finding x, we're going to use the coefficients of y, and we're going to use our answers. So it'll go like this: m, n, b, and g. If you think about it, an xy point goes x and y. Y is on the right side. Well, here the coefficients of y are also on the right side, and our answers are going to be on the left. So when we're looking for x, we use the coefficients of y and our answers. Now, all of this is on top of the determinant of our coefficient matrix. Okay? Now, the solution for y is going to be the determinant. It's going to look very similar, except what's going to change is we're no longer going to use the coefficients of y. We're going to use the coefficients of x in x's spot. X goes on the left, so our coefficients of x are going to go over here. And we're going to use our answers again to fill in the rest of the matrix. Now, all of this is again over the determinant of our coefficient matrix. Okay? That right there is the basic form for using the Kramer's rule. When you're looking for x, you're going to use the coefficients of y with your answers, determinant of that matrix over the determinant of your coefficient matrix. When you're looking for y, you're going to use your x coefficients in the x spot with your answers, and all of that over the determinant of our coefficient matrix again. So it's nice because once you find the determinant of your coefficient matrix when you're looking for x, now you can just plug that in and use it to find plug it in right here for when you're finding y. So let's practice this and let's try an example. Let's use this system right here. We're going to go 7x plus 3y equals 37. And let's go negative 5x minus 7y equals negative 41. Now, using the tools that you already know how to solve system of equations with, this one wouldn't be that fun. Because if you wanted to use substitution, you'd have to solve for x or y. You're going to be dealing with some nasty fractions, and then you're going to have to plug it back in and solve. If you wanted to use elimination, you'd either have to multiply this one by 5 or 7. You're dealing with this, you're going to get very large numbers. It's not going to be fun. So this Kramer's rule is a nice way to solve these quickly and efficiently. So first, let's figure out our coefficient matrix. This is going to be 7, -5, 3, and -7. That right there is our coefficient matrix. So let's solve for x. So x, it's the determinant of, we have x, so we're looking for x, so we're going to use the coefficients of y and our answers. And you remember where y goes. It goes on the right, just like an xy point. So our coefficients of y are going to go over here, and our answers, -41, go over here. All of that over the determinant of our coefficient matrix. So, up top, we have 37 times -7 minus 3 times -41, and all of that over, using our coefficient matrix, 7 times -7 minus 3 times -5. Again, we're just finding the determinants of both of these matrices. So, up top, this will simplify down to -136, and on the bottom, this will simplify down to -34. This number will be handy to know because when we solve for y, we're going to use this number again. So, -136 over -34 simplifies down to 4. So that's our solution for x. Now, let's keep this number in mind and let's solve for y. So, solving for y, again, we're looking for y, so we're going to use the x coefficients in the x spot. So it goes 7, -5, and then our answers, 37 and -41. All of that over the determinant of our coefficient matrix again. So, up top, we've got 7 times -41 minus 37 times -5. All of that over the determinant of our coefficient matrix, which we figured out when we solved for y, was -34. Up top, this will simplify down to -102 over -34, and our y solution is 3. So, our final answer would be x equals 4 and y equals 3. And if you don't think that that's awesome, I don't even know what to say. We just solved a system of equations with these crazy answers using matrices. Too stinking cool.